Then we need to understand cost in the short run and in the long run. Now, short run and long run means there is no clear cut definition in terms of time period required for short and long. It depends on context. Okay. So, basically the idea of short run is, short run indicates the period in which the firm cannot change both the inputs, labor and capital. One input is assumed to be constant in the short run. Capital means plant and machinery. You can easily understand, for changing your plant size you need time. If you want to increase the plant size, then also you need time. If you want to reduce the plant size, that will also require some amount of time. You cannot change your factory size overnight. That is why capital is assumed to be fixed in the short run, but labor can vary in the short run. And in a long run, when you have capacity to change your factory as well as the labor, that is defined as your long run. Now, for a labor capital intensive firm, maybe for an iron and steel industry, cement industry, or this type of industries, long run may be 10, 15, 20 years. But for a firm like a tea seller or a drinking water producers, short run might be a year or couple of months. So, that is why the idea of short run and long run should be understood conceptually, not in terms of time. Okay? Conceptually, what does it mean? Short run means firm has the capacity to change only one input. Long run means firm has the capacity to change both the inputs, both the adjust both the inputs. Some inputs are fixed, so factory size and the cost of these inputs, as you know, is fixed cost. Long run means all inputs are variable. Firms can build more factories or sell the existing one. Selling also require time, building also require time. Selling does not mean that you will sell it just like that, because you need to find out a suitable customer. You should get a proper price for the investment what you made. That is why both selling and building requires time, and that is why it is defined as long run, because firm requires time to adjust capital size, factory size. So, in the long run, average total cost at any Q is cost per unit using the most efficient mix of the inputs. This is very important. What I am saying, efficient mix of input. If you recall in our yesterday's discussion in the context of ISOQuant, we said that firm can decide which particular combination of capital and labor to use based on the cost. That means the idea of ISOQuant itself is a long run concept, because you have the capacity to change both capital and labor. That means in the long run only firm can select the most efficient mix of inputs and also most efficient scale size. Okay? Most efficient scale size. Firm has the capacity to adjust. In the short run, I cannot adjust that. Okay? So, most efficient scale size, please remember, is a concept defined by a scale size at which long run average cost is minimum. That is called minimum efficient scale size. Look at this. So, here we are measuring average total cost, and in the x axis we are measuring output. So, let us say that there are 3 factory sizes that the firm can choose: small, medium and large, right. So, each size has its own short run average total cost. So, this is ATC when the scale size is short, it is ATC when the scale size is medium, and this is ATC when it is large. Okay. So, these are all short run average total cost depending on what scale you use. So, there are three, that means to change the scale size firm needs time, right. It cannot change overnight. You have three different ATC depending on your scale size the firm might be having. Now, the firm can change to different factory size only in the long run, but not in the short run. So, in the short run these are fixed. Firm can go from ATCS to ATCM only in the long run, ATCM to ATCL only in the long run. So, when the firm is producing an output within QA, firm will choose S in the long run, okay, size X. So, that is the factory size. Factory size can be selected, firm will select this in the long run, and then this is the factory size when the output is between QA to QB, and this is between beyond QB. Okay. And if you add these three ATC with an envelope, that is called long run average total cost. Okay. So, that means the firm might be having in reality many such. In the real world, factories come in many sizes, okay, many sizes, and each with its own short run average total cost. Okay. So, each of these scale size small ATC, it has its own short run ATC. Okay. Each factory size has its own short run ATC. If you take the envelope of this, then you will get long run average total cost curve. So, basically the idea is simple. Long run is the summation of many short run. Okay. A long run is the summation of many such short run, and in each and every short run you have one ATC depending on the size. Depending on the factory size, you will have many such short run. So, if you can make an envelope of all those short run, what you will get? You will get a long run average total cost curve. Now, in this figure, one interesting thing is that at the left side of the ATC, when the ATC is falling, see this particular curve is touched on the long run average cost towards its left side. So, that means even though this curve is minimum here, production is happening here, because it is the short run. Firm is not able to change the scale size. Then when you go to the second one, it is touching the curve little right side. Why is this so? So, that means from here to here, since the minimum point of the short run ATC lies right side of this, firm is enjoying economies of scale. That means firm is producing more and more output. That is why tangency is happening towards the right side of each and every short run ATC, And look at this particular ATC, where the ATC, short run ATC, is touching the long run ATC at its minimum point. Okay? And this size, when short run ATC is touching the long run ATC at its minimum point, that is the minimum scale size. Minimum scale size. Okay? So, that means minimum efficient scale size, I will say. So, you must produce here to minimize your cost, but this is not possible, please remember, in the short run, because you cannot adjust towards the scale size in the short run. That is why for all the short run, tangency is happening towards the left side of the each and every short run ATC. So, you can increase your output, Final adjustment is happening only here in the long run, right. So, ATC long run looks like this. Economies of scale, as ATC, that means average total cost is falling as you are increasing your output. Why this is so? As you keep on increasing, that means, see, for increasing, when you are producing, you need to hire a big machine, some laborers. So, when you increase the size of your production, what is happening? Average cost is falling, because there is economies of scale, average cost is falling. And when you increase the scale size, that means you are increasing both capital and labor. The laborers are also, more labor means specialization of laborers also is happening. Earlier, let us say you are having only 2 laborers. Those 2 laborers are only doing all the works at the factory. Obviously, they would be inefficient. When you increase the scale size, you are hiring more. Laborers are getting more labor, means they are having specialization, and if specialization happens, that will lead to more and more output. At the same time, you must increase the capital size also, because the laborer must get enough machine to work. All these things actually explaining the diminishing or falling portion of your long run average total cost curve due to economies of scale, more output leading to fall in average total cost curve. At some point of time, it is basically constant returns to scale. Okay. What does it mean? It means that returns to scale basically means, if you increase your capital and labor by, let us say, 5%, what is the percentage change in your output? Okay. For example, here I can give you an example. Let us say Q is a function of K and L. So, you are increasing K by 5%, L also by 5%. When capital and labor both are increasing by 5%, what is the increase in your output? If it is 5%, if output also increases by 5%, that is known as constant returns to scale. If output increases by 10%, it is known as increasing returns to scale. Okay? That is why average cost is falling, and when output is increasing by, let us say, 2%, it is called diminishing returns to scale, or diseconomies of scale, long run average cost will go up. So, again, please keep in mind, returns to scale is a long run phenomena, because returns to scale by definition, it means increasing both capital and labor, changing both capital and labor, and that is possible only in the long run. If you increase one factor keeping other one constant, then that is known as returns to factor. Please keep in mind, returns to factor. That means changing only one of the factor of production, keeping the other one constant. So, returns to factor is basically a short run phenomena, and returns to scale RTS is a long run phenomena. So, we are explaining the shape of the long run average total cost curve with the help of returns to scale. Initially, it is increasing returns. So, that means economies of scale. When there is economies of scale at this portion, what is happening? You are having increasing returns to scale or IRS, because economies of scale. Here it is CRS and here it is DRS. Why DRS? Because you are getting diseconomies of scale. When you employ too many laborers, too many capital, too much of capital, then the manager will find it very difficult to coordinate with each and every labor and capital. As you know, big organization requires bigger coordination, and if coordination fails, then you will get diseconomies of scale, and that means your total cost will increase. Okay, average total cost will increase because the incremental change in capital and labor contributing lower and lower amount of output. Okay. So, very important concept we have understood. Please keep in mind, returns to factor and returns to scale. Returns to factor means only one factor of production is changing, keeping the other factor of production constant. So, it is a short run phenomenon. Generally, in the short run, we keep capital as constant, and that is why we consider returns to labor. If you feel no, labor is constant, capital is changing, then returns to factor with respect to capital, depending on the context. But returns to scale means you are actually changing both capital and labor, which is possible only in the long run. So, that is why in returns to scale is a long run phenomenon, and we have three different types of returns to scale: increasing returns to scale, constant returns to scale, diminishing returns to scale, depending on how the output is changing with respect to increase in your both capital and labor. Okay. Remember, we are changing both capital and labor. When the output is changing by the same, we call it CRS. When it is more, we call it IRS. When it is less, we call it DRS. Okay. So, this is the long run average total cost curve, and please remember, the minimum point of this long run average total cost curve is also known as minimum efficient scale size. Okay. Minimum point of the long run average total cost is known as minimum efficient scale size. All right. So, there diseconomies of scale this particular portion where you are getting diminishing returns to scale also, right. So, how ATC changes as the scale of production changing? Economies of scale occur when increasing production, that means changing capital and labor allows greater specialization. As I told you, workers more efficient when focusing on a narrow task. So, initially when you are increasing labor and capital, division of labor, specialization of labor is happening. That is why everybody is focusing on a narrow task. Earlier the two laborers or one labor was doing everything. Obviously, when you are doing everything, you cannot specialize, you would be inefficient. Okay. One labor is doing everything in the factory, inefficient. When there is more laborers, when you are increasing the scale size by hiring more labor, increasing the size of your factory, so laborers are getting time to specialize. They are focusing on a narrow task, we are enjoying economies of scale. You will enjoy increasing returns to scale because of these economies of scale. So, this is happening, this happens when output is low, then if you increase, this will happen. But these economies of scale means when the size is too much, then there would be coordination problem. Management becomes stretched, can't control the cost. That is why there should be some efficient scale size. The farm size should not be too big, because you will get diseconomies of scale, coordination problem. The farm size should not be too small also, because your cost of average cost will be much higher. So, as long as you are getting economies of scale, you should increase your factory size, you should increase scale of production. You should stop at a point when it is average total cost starts increasing. Okay. That is why the minimum point of long run average cost curve is called minimum efficient scale size. Okay. So, what we learned in this particular chapter? Implicit costs do not involve a cash outlay, but still they are as important as the explicit cost. If you do not include implicit cost, your cost calculation would be wrong. Accounting profit is revenue minus only explicit cost, but economic profit means total revenue minus total cost. The production function shows the relationship between maximum attainable output and the inputs given the technology. Okay. And then the marginal product of labor is basically the change in output for 1 unit change in labor. Okay. And marginal product of labor is actually constant. Sorry, a marginal product of labor falls as you keep on increasing the output, and that explains why the production function gets flatter at after certain point of time. Marginal product usually diminishes as the input increases. Thus, as output rises, the production function becomes flatter. Total cost curve becomes steeper. Okay. Then variable cost vary with output, but fixed cost they do not. Marginal cost is the change in total cost from an extra unit of production, and marginal cost curve is also upward sloping. Average variable cost is variable cost divided by the output. Any average concept is very simple, whether it is average total cost, average fixed cost or average variable cost. You take variable cost divide by output, AVC. You take fixed cost divide by output, you get AFC. You take total cost divide by output, you get ATC. Okay. Average fixed cost is fixed cost divided by output, that is why it falls continuously. And average total cost is the cost divided by quantity of output. It initially falls and then increases. So, usually U-shaped. And this is the most important relationship, as I told you with the example of CGP and GPA. As long as your MC is less than ATC, ATC will fall. As long as your GPA is less than CGPA, CGPA will fall. And then if GPA is more than CGPA, your CGPA will go up. In the long run, all costs are variable. If there is economies of scale, ATC will fall as Q increases. In between, there is constant returns to scale, and then ATC will rise. With this, we are closing our discussion today. Thank you.